So this was asked in 1990. There are two parts of the question. First part is convert this grammar into operator grammar. After that, construct the parsing table, precedence relation table. So let us first look at how to convert this given grammar into operator grammar. So for that, what I do is, instead of taking such a big grammar, let me just abbreviate each of this in a simpler manner. Okay, just for understanding purpose, I will rewrite the grammar like this. P stands for para, S stands for sentence, R stands for RP. RS, where R can be blank sentence, R blank sentence, where S can be word blank sentence, R word, where word can be letter star word or letter, where letter in simple can be ID. Just abbreviated each of that words into single letter just for understanding purpose. Same thing is rewritten here. Okay, so let me take this grammar and let us see. Now look at this grammar. Is this grammar is operator grammar? Check out here. There is no problem with this, no problem with this, no problem. What are the terms? By the way, what are the terminals and non-terminals here? Here star is a terminal, ID is a terminal, blank is a terminal. Remaining all are non-terminals. So if you look at here, two consecutive non-terminals are not allowed in operator grammar just because of these two. Here and all there is no problem. In between two non-terminals there is a terminal. Okay, but whereas here two adjacent non-terminals are occurring, because of these two rules we say it is not operator grammar. Now let us see how to write the equivalent operator grammar. So for that, look at this. If I substitute for R here, what happens? P can be S, R is what? BSR, R, S, BS, R, S. I have simply expanded this R by these rules. Then what I get? SBSR, SBS, RS. By expanding this by R like this, are we able to avoid that adjacent non-terminals occurring together? Look at this. Once again you have, here there is no problem, here there is no problem, but once again here you have two adjacent non-terminals coming. So how to eliminate this occurrence of adjacent non-terminals here? So best part would be here, SR is what? P. So rewrite this as P is SBP, R, SBS, RS. Then what happens? You don't require R at all in that case, whereas the remaining three can be as it is. So look at the resulting grammar. S2 W BS R W. W can be L star W R L, L2 ID. This is your equivalent grammar. The only thing what we did is, after expanding this R by this, once again since you are getting SR, two adjacent non-terminals are not allowed. SR stands for P, so hence I have replaced this with a single non-terminal. That is how you can always rewrite the grammar into equivalent operator grammar. Now once we have this, the second part of the rule is, what it says is, use this grammar and define the parsing table for parsing the input expressions of the form something like ID star ID blank ID star ID. So to parse this input string by the parsing algorithm, naturally we require precedence relation table. So let us prepare the precedence relation table here. Okay, let us construct the table. Terminals are ID star blank dollar, ID star blank dollar. Look at the grammar. So if you consider these are the terminals or the operators in the grammar, what is the precedence difference between star and blank here? Star is defined at the lower side, so star has the highest precedence compared to blank. And other thing what we can understand here is regarding the associativity. Precedence difference between the two operators is star has higher precedence than B blank because star is defined at the lowest level. And coming to the associativity, the rule is right associative, that means star has higher precedence than blank, and associativity is star is right associative. Remember this, rule is right recursive, whereas this one blank is also right associative. Okay, just keep that points in mind. Let's prepare the table. How do we prepare the table? Take some input string. Let me take an input string something like id star. Because I need to parse this input string, let me take the same input string. What is the procedure I said? It's a reverse engineering now. So take this between two symbols. So here what is the first handle that is to be reduced? id has the highest precedence, so the simplest handle here is id. So at the first level all ids are to be reduced. So if I want to ensure that all the ids are to be reduced at the first level, how do I ensure? Insert every id between less precedence and greater precedence. This will ensure that all the ids are reduced first. Insert the relations. Dollar on id less, id on star greater, star on id less, id on blank greater, blank on id less, id on star greater, star on id already defined, and id on dollar greater. So with this what happens? All the ids are reduced. Now I am left with star blank star. Now which is to be reduced first? Now there are two different operators. What did we say? Star has higher precedence than blank. That means star is to be reduced first. How do you ensure that star is reduced first? Insert every star between greater precedence and less precedence. So what did I say? Dollar has less precedence to star. Star has greater precedence to blank. Blank has less precedence to star. Star has greater precedence to dollar. So with this what happens? You will be left with only blank. Now this is reduced. So dollar to blank is less, blank to dollar is greater. So only these many relations in the relation table would be sufficient for parsing this given input string. But if you really want to complete the table, let us see what are the entries that are missing. id to id, no relation. Dollar to dollar, no relation. These two will be blank. But what about star on star? Star on star, how do we define? Here associativity is what? Right. Right associative means less precedence. Similarly, blank to blank is also right associative. Right associative means less precedence. This is how you can prepare the precedence relation table. No need to mug up all the rules. And once you have this rule, by using that simple digraph construction, you can reduce even this to function.